In this video, I'm going to solve a few questions on section 4.2 and 4.3 homework assignments. This question is from section 4.2. The Blackstone Speedway is a supplier of automotive parts, and include in the stock we have 11 speedometers that are correctly calibrated and 2 that are not. So you know that we have 11 of them, and 11 are good, and we have 2 that are not good, so 2 bad one. So together we have the 13 total. 3 speedometers are randomly selected without replacement. So you take it out, you do not put it back. Let x be the random variables that represents the number that are not correctly calibrated or the bad one. Complete the probability distribution table. So they ask you, what is the probability of you getting the 3 bad one? Well, we have only 2 of them, so there's no way that you can get 3 bad ones, right? So you cannot get this probability. This event cannot happen, does not exist, or you should have 0. What happens if I want P of 0? That means when I select out 3 of them and none of them are the bad one. So when let's find P of 0. When I select 3 of them out, I want all 3 of them belong to the good one, because I don't want to have the bad one, because I'm looking for P of 0, and 0 represent 0 bad one. So 3 of them I want they are only the good one. So because you want the good one, so we focus on the good portion. We have 11 the good items, right? 11 out of the total. So the first time when you take out the first speedometer, you want that to be the good one, so 11 out of 13. Because we do not replace it back, so we only have 12 items for the next time that you take out the second one. And you are still looking for the good one because you already took out the good one, so we only have 10 left. And then lastly, we only have 11 items left, and we only focus on the good, so there are only 9 of them left. So this is the case where you will not get any bad one. So 11 over 13 multiply 10 over 12 multiply 9 over 11. You should get this value right here. Now the next one is tricky. They ask you, what is the chance that you get one of them is the bad one? You took out 3 of them, but they ask you, what is the chance that one of that will be the bad one? So we have a few cases. So let's focus on the second case. So you have the 3 items. So we have a few cases. The first case, the bad one could be right at the beginning. So it could be here. The bad one could be here, right? It could be here. And then the other 2 are the good one. Or you may get another situation where the bad one occur at the second position, and the other 2 are the good one, right? We are looking for one bad one. And then you may get another case where you get the bad one is the last. It happens at the last time that you draw the items out. It here, and then the other 2 are the good one first. So let's do step by step. So the first one, it happens that the bad one is occurring right in the beginning. So we have 2 belong to the bad one, and we have 13 of them in the beginning, right? So 2 over 13 multiplications. Because we take out 1, we do not put it back, so we only have 12 left. and now we are looking for the other two are the good one. The good one we have 11 out of 12, and then finally we have another good one, so we have 10 because we already took out 1, 10, and we only have 11 left. So that is the first situation. Now the OR means we are going to add. Okay, so this is the whole value, right? And then you add to the second situation. The second situation is when the bad one occur in the second time that you take out the speedometer, right? So the first one would be the good one. The good one 11 out of 13, and then you only have 12 items left, and you want the bad one for the second 2, and then again you want the good one again. So 11, now we only have 10. And then another OR means addition. And the last situation, the bad one is right here, so the other one is the other first 2 would be the good one. So 11 now of 13, and then 12, and we have 10 only. And then of course we only have 11 left for you to pick out. And then of course you want the last one to be the bad one, and you have 2 of them. So you add this thing, add to this thing, add to this whole thing. You should get this value. And then I would leave you to do the second case here. So the last case we are looking for P of 2, right? So that is simple. You are looking for 2 bad items, right? So out of 3, you want to have 2 bad items. So that we still have a few situations. The 2 bad items may be here and here, right? Or you can put add for the OR, right? Or it could be the last 2, right? Here or here, and then the first one is a good one. So basically you only have the first 2 or the last 2, or you can also have another case where the bad one belong to the first and the last time that we take out the speedometer, and then the middle one is the good one. So actually we only have 3 cases: the 2 here, the 2 first, or the 2 one in the beginning, one in the last case. And then you just follow the same logic that we have here, and you should get the answer. So this is the good one. The good one is 11 out of 13, and you only have 12. And now you want a bad one, 2 out of 12. Another bad one, so we took out 1, you only have 1 left. And then these 2 are the bad one first, so we have 2 out of 13, and then 1 out of 12. And then finally we have the good one. The good one only have 11 left, and the good one we have 11. Of course the last one must be the good one, and 11 out of 11 mean 1 or 100% for sure. Here is the bad one, right? So 2 out of 13, and the good one 11 out of 12, and then the bad one again 1 out of 11. And just add them together, you should get to this value here. And to find the mean of this probability distributions, again you can find the mean by multiply the x and the p of x together, right? So take 0 multiply with this value and add to 1 multiply with this value, x multiply with p of x 0.3846, and plus 2 multiply with this value 0.0385, and plus 3 times 0. And you can see that 0 times this thing is gone, 3 times 0 is gone. So basically you only have these 2 values to multiply. So this thing multiplied by 1 is just the same thing, right? So 0.3846 add to 2 times the other one, 2 times 0.0385, and you can round it to 1 decimal place, and 0.4 because after the 4 is number 6 and this is bigger than 5, so you add 1 more to here, 0.5. So 0.5 is your answer. This next question is about the binomial distribution function for discrete random variable. So suppose that a box contains 6 cameras and that 3 of them are defective. So in this case, again, we have the 6 total for the number of the camera, 6 total. And then inside the 6 total, 3 of them are the bad one, right? 3 defective. And therefore, the other 3 should be the good one. A sample of n equal, a sample of 2 cameras selected at random. So the number of the trial is n equal 2. And then we define the random variable x as the number of the defective camera. So we are looking for, this is the binomial probability, so we can use the function binomial Pdf. And this function of the TI-84 will take the 3 inputs, the number of the trial n, the p, the probability of success, and the number of the x that we are having here. So again, n is the number of the trials. We have 2 cameras selected, so n equal 2. P is the number of the probability that you get the good one for success. So remember, we have 6 is the total, so 3 good one, or 1/2, or always 0.5. And then x is 0, 1, 2, because you have 0, 0 for because you are selecting 2 camera, right? 2 camera, so you may get no bad one at all, so 0 bad, or 1 bad, or the maximum is 2 the bad one. So x is the number of the bad one. Alright, so I'm looking for p of x equals 0. So I'm using x equals 0. So I'm using the function Binomial Pdf of your TI-84, and it's 2, the number of the trial, and p is 0.5, and x is just 0. So we can do that here. Go to second var distribution, go all the way down to Binomial Pdf, trial 2, p 0.5, x is 0. And that gives me 0.25, which is right here. And then I switch x to 1, so I go back to here, I second enter the entry, and then I just move 0 into 1, and I get 0.5 for the answer. And then finally for 2, I just go second enter, and then I fix this into number 2 and 0.25 right here. And to find the expected value, you're gonna take 0 multiplied to 0.25, you're gonna add to 1 multiplied to 0.5, x multiplied to p of x, right? The summation, remember, summation of x and p of x, this is the expected value. And then again, last one, 2 times 0.25, and then you add all of them together, this is 0, so you should get 1 right here. And this is the question from section 4.3. Let's do another question about 4.3. A binomial distribution, binomial experiment. Again, binomial means you will have 2 outcomes, success or failure, right? Or you can think this is as a good one and this is as a bad one. So this binomial experiment consists of 19 trials, so n equals 19. The probability of success on the trial, again, success is denoted by the letter p, small p. On trial 12 is 0.65. What is the probability of success on trial 16? Right. So how do we do that? Again, n is 19 trials, which is everything, and 12 is the individual trial for x. We call this x, and also this is another x. So in this case, we are looking for the probability of the getting success on trial 16. So again, if you recall your binomial PDF functions on a TI-84, we take the input of n, of p, of x. X is the number that could vary, in this case 12, 16, 10, 11 until 19, and n is always 19, so n is always 19. This x value could vary from 0 up to 19, and again p is the probability of success, and this p value must be fixed, must be a fixed value. So you must have a one single value for any value of x. So in this case, because we know that the probability of success on the number trial of 12 is 0.65, this is the p-value, and therefore on any given trials number, you should always get 0.65. So p is the fixed value.